Hi, everyone. We're going to talk about derivatives of log functions. And specifically for us, we'll mostly key in on the natural log function. So here in the yellow box, we've got the rules for this. If you have the natural log of x, then the derivative of that is just 1 over x. So this is the basic rule. And again, it only works for natural log of x, not natural log of x squared or natural log of 2x, only natural log of x. Okay. Now, if you do have natural log of something more complicated, right? So say you do have natural log of 2x or natural log of x squared or anything more complicated than just plain old x, then the derivative is going to be 1 over whatever is in the log multiplied by the derivative of that. So the chain rule version. Another way to write it, I've written it up here, is, if you have the natural log of some stuff, then when you do the derivative, it's going to be 1 over all that stuff times the derivative of that stuff. So that's just the chain rule version written in a, I guess, shall we say, a more informal way. All right, so that's what we're going to practice. And again, just like in the previous section, all of our old derivative rules will come into play: product rule, quotient rule, chain rule, and so on. Okay, so let's start with A here. We've got -9 times the natural log of x. So if we want the derivative, y prime, -9 being just a coefficient, that's just going to stay there. So we're going to have -9. And then the natural log of x has a derivative of 1 over x. And then the preferable way would be to actually multiply this together. So think of -9 as being -9 over 1. And so when you multiply, we would get -9 over x, and that would be our derivative. And that would be in the simplest form. That'd be perfect. Okay. Okay, let's take a look at B. So B, we have the natural log of 3x. So again, something more complicated than just plain old x. So we will have a chain rule here. So y prime is going to be 1 over that stuff, so 1 over 3x. But then because 3x has its own derivative, then you have to multiply by the derivative of 3x. What's the derivative of 3x? Well, it's 3, actually. Now we clean it up. So this one is our example of our chain rule here. Okay. All right, and if we clean it up, let's see, 3 times 1 over 3x will be 3 over 3x. And wow, surprisingly enough, if we cross cancel those 3's, we're back at 1 over x. That won't always happen, but in this case, that's where we ended up at. Okay, so there's an example of how that chain rule version would work. Okay, let's keep going. Problem C, we have the natural log of, well, kind of a mess. This is our chain rule again. So we're going to use our chain rule. And I'm going to kind of think of it in the informal way. So when I do my derivative, it's going to be 1 over all this stuff, e to the x minus 2. Okay, 1 over that. But then I have to times it by the derivative of e to the x minus 2. Well, the derivative of e to the x, that's what we learned last section, is just e to the x. And the derivative of -2, well, that's just 0. So we'll drop that out of there. So what are we left with here? Let's push this together and make a final answer. So y prime would be, if I multiply this, e to the x times 1 is e to the x over e to the x minus 2. And that would be reduced. There's no reducing you can do there, because unless you can factor something out and cancel, that's it. You're finished. Okay. All right, so this doesn't seem too bad, right? So natural log, you just follow that rule, 1 over whatever's inside, and then chain rule it. Okay, problem D is a little different. Problem D is a composition of functions. You have a natural log inside of an exponential function. Okay, so that natural log is inside of a x to the 4th function. So being that it's a composition, we are going to do a chain rule, which, remember, is the derivative of the outside. The outside of this would be the power of 4 times the derivative of the inside. So when I do this derivative, y prime, I start with the power rule. So I bring the exponent of 4 to the front. And remember, you leave the inner part the same when you do this. So power rule, 4 to the front, lower it by 1, so it becomes to the third. So remember, this log of x is the inside function. So then I have to multiply it by the derivative of the inside. Well, we just learned the derivative of natural log of x is 1 over x. And so that would be what this derivative looks like. Now I'm going to make this look a little bit nicer, but again, chain rule. So I did that outside exponent first, derivative of the outer part, which is bringing 4 to the front, lowering it by 1, and then multiply by the derivative of the inside. So this right here, this was my derivative of the inside, meaning that log of x. All right, let's just write it a little nicer. So the derivative will be 4 natural log of x to the third power. Let's put the whole thing over x, right? Pushing that together, just multiplying those two fractions, and there's what we get. Okay. All right. Onward we go. Let's do one of these. So E and F, we have either a quotient rule we can practice, or we can try a product rule, right? F would require a product rule. Now, either one will give us good practice. Let's do the quotient rule. All right, so I see here a function on the top divided by a function on the bottom. So this requires the quotient rule, right? No way of getting around it. So again, for myself, I use f prime times g minus g prime times f over the bottom part squared over g squared. So that's how I'm going to approach this. Okay, so here goes, big quotient rule coming up. So y prime is going to equal. All right, let's do the derivative of the top function. So the derivative of the natural log, 1 over x, that's my f prime. Multiply it by the g, which is x to the 8th. So I just write that down. Minus, do the derivative of the bottom function. X to the 8th, the derivative is 8x to the 7th. Multiply that by the top function, which is just the natural log of x. And then put it all over the bottom function squared. So x to the 8th raised to the 2nd power. Okay, so just to help you here, this is the f prime here. This was my g, this was my g prime, and this was my f as I did it. Okay, let's do some cleaning up. Derivatives. So 1 over x multiplied by x to the 8th, right? So doing this part right here, we can cross cancel an x. And so we end up with just x to the 7th there, right? Because that x on the bottom cancels one of the x's with the x to the 8th. Minus, well, nothing we can do with the second part, 8x to the 7th log of x. On the denominator, when you square x to the 8th, 2 times 8, 16. So I get x to the 16th. Okay, let's reduce. Now remember, the way to reduce fractions is you have to have factors. So I'm going to factor the numerator. So on the top of this fraction, I can see that both terms have an x to the 7th in common. Remember, the subtraction sign is what is separating the terms. So I'm going to factor out x to the 7th here. And if I do that, I'll have just a singular 1 minus 8 log of x over x to the 16th on the bottom. Okay. Now I can do some canceling because now I have a factor of x to the 7th on the top and also on the bottom. So I'm going to cancel 7 of these here. Cancel 7 of them down here. So 16 take away 7 leaves me 9 of them. All right, I think I've got my answer here. So 1 minus 8 natural log of x divided by x to the 9th. That would be my derivative using my quotient rule. And it's in a nice reduced form. Okay. All right, so that's our introduction to taking the derivatives of natural logs. Now I'm going to do a second video where we're going to do a few more complicated versions of this. Really important, I'll show you some tricks for doing the most complicated of these ones. All right, so for now, I'll stop and I'll see you in the next video.